Hello everybody, and welcome to another moving mongoose math movie where you get to play the role of the therapist and try to solve all of math's problems. Today, we're going to be covering lesson 1.3, Properties of Addition and Subtraction. This is on page 16 in your book. So get out your book, turn to page 16, get out your notebook, and we have a few things that we need to cover today. Let's get started. The first thing that we're going to be looking at today is the equivalent expressions. In the last lesson we wrote expressions, and in the first lesson we learned how to solve expressions. And equivalent is just another word for the same, or they equal one another. They're expressions that are the same. So if you hear somebody say the term equivalent expressions, they're two expressions that when you evaluate them or solve them, they're going to be the same. So here I have equivalent expressions. I have 12 plus 7 on one side of my equal sign, and on the other side I have 7 plus 12. To find out if these are equivalent, or to prove that these are equivalent, we're going to solve them. On the left side I have 12 plus 7, which is equal to 19. And on the right side I have 7 plus 12, which again is equal to 19. So we can see that these are equivalent expressions because each side is the same. Now let's check to see if the bottom one is an equivalent expression, if these two are equivalent expressions. On the left here we have 6 plus 1, which gives us 7. And on the right we have 7 plus 1, which gives us 8. That is not the same, so these are not equivalent expressions because they don't equal the same number. That's all we need to know about equivalent expressions. We're going to be finding them and creating equivalent expressions for this lesson and for lessons coming up. We need to know a few properties to make this work, so let's go over a few of those right now. The first one is commutative properties, and remember we're just dealing with addition and multiplication. We're not dealing with subtraction and division. These only work for addition and multiplication. So commutative properties is when you change the order of add-ins in an addition problem or factors in a multiplication problem. So let me give you an example. Add-ins is addition. You have 5 plus 8, which is going to be equal to 13. But by the commutative property, it doesn't matter if you switch the order of those add-ins. 5 plus 8 is 13, and 8 plus 5 is also 13. The same can go for multiplication as well. Let's say you have 5 times 8, and you can use the commutative property to switch those around to move the order and get 8 times 5. Are they still the same? Are they still equivalent? 5 times 8 is 40, and 8 times 5 is also 40. Now this only works with addition and multiplication. If you try to do this with subtraction or division, you're going to get the wrong answer. So I want to stress to you that you can only use this with addition and multiplication. Once again, commutative properties is where you're changing the order of add-ins or factors. Sixth graders, I always write this down in your notebook, these words that are yellow in your book. I'm going to do it this lesson and a few others, but I might not simply lay it out all the time like this. Just know that those yellow words are important for you, okay? So commutative property, you switch the order of either an addition problem or a multiplication problem. The associative property, this is when you change the group of add-ins or factors. You'll notice here on this problem that in the first expression on the left side of my equal sign I have 7 plus 4 plus 2. On the right side is 7 plus 4 plus 2. So the numbers are in the same order. They haven't moved any, so I know it's not a commutative property. But look at the parentheses. In the left expression, the parentheses are around the 7 and the 4. And on the expression in the right, the parentheses are around the 4 and the 2. When this happens, when the parentheses move, it's going to be the associative property. And as you know, according to PEMDAS, or the order of operations, you have to do what's in the parentheses first. So let's see if changing the parentheses in an addition problem changes what answer you'll get. On the left side, since the parentheses are around the 7 and the 4, I need to add those two together first. 7 plus 4 is 11, and then you add 2 to that and you get 13. Now on the right side, we're going to check if these are equivalent, and on the right side, the parentheses are around the 4 plus the 2 first, which means we need to add 4 plus 2 first, and when you add 4 plus 2, you get 6, and then we have to add the 7 to that, and 7 plus 6 is 13. So it doesn't matter, as long as it's addition, what numbers you add together first. And the same can be said for multiplication as well. Let's try this with multiplication. If I were to change the addition signs to multiplication, 7 times 4 times 2, 7 times 4 times 2, and let's put the grouping symbols there and the parentheses there. And now let's check to see if it works with multiplication. On the left side, we're going to do what's inside the parentheses first. So 7 times 4 is 28 times 2. 28 times 2, you know what 28 times 2 is? It's 56. So we know the left side is 56. And on the right side, we do 4 times 2 first because the parentheses are around the 4 and the 2. So we get 4 times 2 is 8. And then 7 times 8 is 56. So we can see that the associated property works for both addition and for multiplication. You're also going to see that these properties can be expressed using variables as we have here. You'll notice on the top, you have A plus B equals B plus A. All you need to remember is that A and B stand for two different numbers. So when you A plus B equals B plus A, can you think of what property that is? That's going to be the commutative property of addition. And I know it's commutative because they're in a different order, and I know it's addition because there's an addition sign in each of them. The bottom one is commutative property of multiplication. Here we have A times B, and down here, or over here, excuse me, we have B times A. They have switched their order. Here we have the associative property of addition. A plus B plus C, and A plus B plus C on this side. It's not commutative because nothing is switched the order. It's still in the same order, A, B, then C. What has switched is the groupings or the parentheses. On the left, you can clearly see that A and B are grouped together, and on the right, B and C are grouped together. So this is the associative property of addition. The same thing would happen with multiplication as well. If you did A times B times C and grouped those together, and on the other side, you did A times B times C and grouped those together. It would be the same thing. It's in the same order, A, B, and C, A, B, C, except the grouping, you're going to multiply AB first on this side and BC first on this side. This is example 1, letter A. The instructions say to simplify the expression 7 plus 12 plus x and to make it smaller. Simplify is just to make it smaller. The way it's written, it wants us to do 12 plus x, but I can't do that because I don't know what number x is. So to simplify this, I'm going to use my associative property of addition, and I'm going to rewrite this problem, but I'm going to move the parentheses so that they're around the 12 and the 7. And 12 plus 7, I can do that first now, is 19. And we're going to add x to that. And this is the simplified form when you can't do any more with it. That's the simplified form. On example letter B, I'm going to use the commutative property of addition, and I'm going to change the order so that I can group what I can add together. I'm going to keep 6.1 where it is at, but then I'm going to switch the x and the 8.4. And remember, I can do this because we just went through the properties, and it doesn't matter what order we add any numbers in, as long as we're adding them, we'll get the same answer. So I'm going to switch the 8.4 and the x, and then I'm going to add the 8.4 and the 6.1 together. 8.4, remember when you're adding decimals, you need to make sure that your decimal is always lined up, and then add like normal. 4 plus 1 is 5. Bring down your decimal, straight down. 8 plus 6 is 14. So my answer is 14.5. And don't forget you need to add that x on there. And because it's an x and you don't know what number it is, you can't add it. And so this is the simplified expression. Last example, example C. It reads, remember 5 times, when you see those parentheses with no addition or subtraction, it's times. So it's 5 times 11 times y, or 11y. And we're going to use the associative property of multiplication, and we're going to move those parentheses signs so that they're around the 5 and the 11 instead of the 11 and the y. So all I've done, this is kind of tricky, all I've done is I've taken the 11 and I've put it next to the 5, put my multiplication sign in there, and then moved the parentheses around the 11 and the 5. So that way, whoever is solving this knows they need to multiply the 11 and the 5 first. And then the y happens to be by itself for now. Let's solve what's inside the parentheses first. 11 times 5, we know is 55. And we can't, don't forget the y, we can't multiply it by anything because we don't know what number y equals like we did in the first section. So our answer is 55y. You're going to try a couple on your own. This is number 1 on page 16 at the bottom. Here's where I want you to pause the video. I want you to use whatever property you think you can use to simplify this expression. Pause the video and work it out. Alright, to solve this one, you would need to rearrange, use the commutative property to do 10 plus 9 plus a, and then I would also use the associative property and move the parentheses so that they're around the 10 and the 9, and we're going to do 10 plus 9 first and get 19, and we still have that a at the end, but we can't add it because we don't know what number it is, so we're left with 19 plus a. Here's example number 2. I want you to pause the video and see if you can solve it. And actually, I've already given you a hint of what you need to do. So hopefully, you'll be able to get it from here. But pause it, and then unpause when you're ready. The original problem is written as C plus 25.3 in parentheses plus 17.9. So what you would do is you would use the associative property of addition, and you would move those parentheses around the 25.3 and the 17.9. And then you would add what's inside the parentheses together. So 25.3 and 17.9. Remember, keep your decimals in a line. 9 plus 3 is 12. Carry the 1. 7 plus 5 is 12. Add the 1 is 13. I don't know why I just put 2 decimals there. There we go. And then you have to carry the 1. And once you carry the 1, you have 2 plus 1 is 3 plus 1 is 4. So we have 43.2, and don't forget we have the C. So our answer should be C plus 43.2. And if you did 43.2 plus C, do you think that's correct? Well, sure it is. because C plus 43.2 and 43.2 plus C are equivalent expressions. It doesn't matter in what order you're going to add it, you're going to get the same answer. Okay, here's on your own example number 3. You have 5 times 4n. I want you to see if you could simplify this. Pause the video and unpause when you got your answer. Okay, I would use the associated property of multiplication to regroup what's in my parentheses. And I would change the parentheses to be around the 5 and the 4. And don't forget that's multiplication. So we would get 5 times 4, which is 20. And then we're just left with the n. So your simplified expression should be 20 times n. 2 more properties that we need to cover. And these will be the easiest, and you'll probably like these the best. The first one is the addition property of 0. And all this says is when you add 0 to a number, the sum, or the answer, will always be that number. So notice in your book it says 7 plus 0 is going to be 7. Right? That makes sense. And then that's also true with algebra if we were to use variables. B plus 3, or not, you can't do that. B plus 0 is going to be B. Any number you add, and you add 0 to it, is always going to be the number, correct? So 1,234 plus 0 is going to be 1,234. Once again, we call that the addition property of 0. Pretty easy, right? The next 2 that we're going to cover is multiplication, and these are easy as well. The first one is the multiplication property of 0, and all that is any number that when you multiply it by 0 is going to be 0. So 1 times 0 is 0, right? 500 times 0 is, according to the property, 0, right? C times 0 is 0. It doesn't even matter what C is. That's an easy property to understand. And the last one is easy as well. The multiplication property of 1. Any number multiplied by 1 is that same number. Makes sense? We know that 5, let me get it here, 5 times 1 is that number, which would be 5. 10 times 1 is 10. 150 times 1 is 150. Okay? It can go on and on. It doesn't matter what number it is. 1,000 times 1 is, hopefully you said 1,000. Okay? So that property is pretty easy to understand, and we're going to be using that in our homework. And let's do a couple of examples real quick. Alright, here's example number 2. This is letter A. It wants us to simplify this expression 9 times 0 times P. Alright, so let's do that. We can group this together because we can do 9 times 0. So I'm going to use the grouping there. And 9 times 0 is 0 according to our 0 property of multiplication. 0 times P is 0. Anything times 0, no matter what it is going to be 0. Alright, this expression, 4.5 times R times 1. Let me make that times sign a little bit better there. It's not a decimal, it's supposed to be times. And I'm going to use the commutative property to rearrange it, I guess, first, because I just want to. Because it doesn't matter what order you multiply it in. So I'm going to multiply this first. 4.5 times 1 is 4.5. And then you have to multiply that by R. We don't know what R is, so we're just going to write it as 4.5 R, or 4.5 times R. And then we're done, and we're simplified. Well, that brings us to the end of what we have today. A little bit long. Hopefully these properties make sense and that they are understandable to you. So I'm going to leave you with one more really corny joke. And that joke is this: why don't they ever play poker in the jungle? The answer is because there's too many cheetahs. That is corny, isn't it? Alright, well, thank you for tuning in. Remember that you're special, and remember that God loves you. See you next time.